655 Part 3, we deal with an average value of a continuous function over a closed interval. To find that, you take 1 over the difference of the upper and lower limit, and then the definite integral from a to b. So let's look at this example, average value of a function. Find the average value of f of x equals x minus 3x squared over the interval -1 to 2. So using the formula, I know it's 1 over, here's your a, and here's your b. So it's 2 minus -1, the integral of a to b of the function. So I can go ahead and simplify this part. And then taking the antiderivative of what's inside there. So x squared, I think I'm just going to go ahead and do this. It's going to be 1/2 x squared minus x to the third from -1 to 2. So taking the inside here, we have 1/2 2 squared minus 2 cubed minus quantity 1/2 -1 squared minus -1 to the third. Simplifying that, one half times 2 squared is 1/2 times 4, which is 2 minus 8 minus -1 squared is 1, so this is 1/2. -1 cubed is -1, so this is plus 1. 2 minus 8 is -6, minus 1/2 is -6.5 plus 1 is -5.5. Let's see, -6. It's -7.5, which is -15/2, which equals -5/2. And if you look at the graph, there you can see the average value is drawn as the line, y equals -5/2. And again, it's taking an average value. Okay, so you have an example to try. Again, so that you can see this. Or in this case, g of t dt. Looking at this as an application, finding the average price over a supply interval. So I do 1 over 60 minus 40, the integral of 100 e to the negative 0.05 x from 40 to 60. So it's 1 over 20. Okay, so this is e to the negative 0.5x. It's going to be negative out front. So negative 100 divided by 0.05. From 40 to 60. Okay, 100 divided by 0.05 is 2,000. So it's going to be negative 2,000 e to the negative 0.05 times 60 minus negative 2,000 e to the negative 0.05 times 40. And you should get, put that in your calculator, $8.56. Okay, so you have this example to try. Again, formula is 1 over b minus a, the integral of a to b, f of x dx.